We're picking up with example 3 of Unit 2, Lesson 10 on graphing reciprocal functions. Before we get into example 3, we're going to look at a key concept on transformations of reciprocal functions. And earlier this year, we've looked at transformations of other kinds of functions. And when we looked at those other transformations, we had horizontal translations and vertical translations. And horizontal, that we always used h, and we used k for vertical, and that's the same for reciprocal functions. You're going to see this expression x minus h, and we're going to go to the right if h is positive, and we're going to go to the left if h is negative. And the vertical asymptote is always at x equals h. And for vertical translations, if k is positive, we're going up. If k is negative, we go down. And the asymptote is at y, or f of x equals whatever that k value is. So previous to this, before we do translations, the horizontal asymptote would always be at y equals 0. But now if you have a vertical shift up or down, the amount that you are shifting is where your asymptote is going to be. And we also have a, and you see up here a is in the numerator of your reciprocal function. And it says that if a is less than 0, the graph is reflected over the x-axis, so it's flipped over. And if a is negative, it's flipped over. If a is positive, it stays above the axis. If a is bigger than 1, it's stretched. If a is between 0 and 1, it's compressed. And this is the same type of thing we looked at when we did quadratic functions and their translations earlier this year. So example 3 says we need to graph the function -1 over x plus 1 plus 3, and then we're going to state the domain and the range. So we know that this is a transformation. The original graph is based off 1 over x, and our a value is -1, which is up here. Our h value is -1. This can be expressed, let's write this out. Right here. This thing can be expressed as x minus -1. It's important to always think of your h expression as x minus something. So h is -1, and our k value over here is +3. So because h is negative, we are shifting left 1 unit. Because k is positive, we're shifting up 3 units. And because a is negative, we're going to have to flip the graph. We're going to reflect it over the x-axis. So this is what our graph looks like. Basically, you can just take some x values, plug them in the function, see what y values you get out, and use those to graph a group of coordinate points. If it's not forbidden by your assignment, you could also just type these expressions in the calculator and see what the graph looks like. But if you are not supposed to be using your calculator, you should just make an XY table around the things that you know to be the asymptotes. For example, remember that since h was -1, we're going to have an asymptote at x equals -1. And because k was 3, we're going to have a horizontal asymptote at y equals 3. So you would pick some values around those problematic points on your graph, and then use the points around those problematic points to create table values, and then plug in the x values and get your answers for y, and then plot the points. And then from that, you should be able to sketch a graph pretty easily. So part B, we've got another one of these. We have this time -4 over x minus 2 minus 1. So we're going to look at our a, h, and k, and our a value is -4 up in the numerator. Our h value is 2, and it doesn't look like we got space here, but k is going to be -1. So combining all that information together, we get a graph that looks like this. Notice that we had to flip our graph over because a was negative, normally the graph would look like this if you follow my mouse, and this up here. But that pattern that I just traced with my cursor is flipped over because A was negative. Alright, let's try a couple check your progress things. For part A, you have 2 over x minus 3 plus 3. So pause the video as long as you need to work this out, and then when you have your answer, come on back and advance to the next screen. And our answer for the first one is choice B. You should have found a vertical asymptote at x equals 3 and a horizontal asymptote at y equals 3, and found that A is 2. So we're going to stretch our graph by a factor of 2. And for part B of Check Your Progress, we have 4 over x plus 1 minus 2. And this time we're just going to look at the domain and the range. So find your asymptote values, and then those are going to be the excluded points from the domain or the range, whichever asymptote you are looking at. So pause the video as long as you need to hear an answer, come on back, and go to the next screen. And our answer this time is choice A. We would have had a vertical asymptote at x equals -1 and a horizontal asymptote at y equals -2. Alright, choice example 4 is we're going to look at how to write an equation, and we're looking at a real-world example on commuting. So it says a commuter train has a nonstop service from one city to another, a distance of about 25 miles. Write an equation to represent the travel time between these two cities as a function of rail speed. Then graph the equation. So the concept here is the faster you go, the shorter the time is going to be. The slower you go, the longer your time is going to be. And there's probably some point in the middle that's an optimal speed and an optimal travel time. For example, if you're, I know this is about a train, but if you're driving on the highway, usually the speed limit is 55 or 65 miles an hour. And, maybe you have to go somewhere in a rush and you want to drive over 65. Well, if you drive 70, if you drive 75, maybe even some places if you drive 80, you won't get pulled over by a cop. But if you go 100, if you go 110, you go more than that, you're definitely going to get there faster, but you're probably also going to have a hefty fine from the ticket when the cop pulls you over for catching you for speeding. So it's not really a good idea to go too much over the speed limit. And at the same time, if you're on a highway and the speed limit's 65, but you are nervous, you're scared of the traffic, you're a beginner driver for whatever reason, maybe you're just not in a rush and you want to drive 30 miles an hour, you're going to get in trouble with the law also, because it's also illegal to drive too slow. It's illegal to drive too far under the speed limit. So there's an optimal speed that you should be driving or moving, whatever mode of transportation you're on, in order to make traffic flow properly. And the same thing works with commuter trains. So we're going to start off with the formula rate times time equals distance, and we're going to figure out what the time is going to be. We're going to get that by itself. We know the distance is 25 miles, but we're not really sure what our rate is. But we want to have our expression in terms of time. So we're going to graph this equation t equals 25 over r. This is kind of like y equals 25 over x. That's basically the concept here. That's how it's similar. So when we graph that, we get this picture. And so you can see, for example, it looks like 5, 5 is a point on this graph. Let me plot that point in blue. So that tells us if our speed is 5, our time would be 5. So if it's 25 miles per hour, if we went 5, If it's 25 miles total and we went 5 miles per hour, it would take us 5 hours to get there. If we went 10 miles per hour, it would take us about 2.5 hours to get there. If we went 15 miles, it would take maybe about a little bit less than 2 hours to get there. If we drove even slower than 5, let's pick this point. It would take 15 hours if we went about, I don't know, 2, 1.7, 1.8, somewhere in there. If we drove really slow, the time would increase. The faster we drive, the less the time is. So this time for part B, what we're going to look at is explain any limitations to the range and the domain in this situation. So our answer, it says the range and the domain are limited to all real numbers greater than 0 because negative values do not make sense. What they're saying here is you can't have a negative time that it takes you to go anywhere, and you can't have a negative speed that you drive or that you move. You can't move in negative speed. It also says there will be further restrictions to the domain because the train has a maximum and maximum speeds at which it can travel. So for example, maybe the train, maybe its optimal speed, the speed that it chooses to travel at, maybe that's 50 miles an hour. But you know, man, if I could drive 200 miles an hour, I'd get there even faster. Well, maybe the train can't possibly go 200 miles an hour. And there's also going to be some minimum speed that it would travel. And I would assume the minimum speed would be like 1 mile per hour or something like that. But it's possible it would have to go a little bit faster than that, because maybe if you tried to go 1 mile per hour, maybe it would be too heavy. Maybe it would require a bigger engine. I don't know. I'm just rambling and guessing now. But there's some other restrictions, but you don't know what they are, and they don't give you any other information. So there are others, but you're not concerned with what they are. You don't have to figure out what they are. All right, we're going to do some check your progress stuff. Pause the video, read through the problem. When you have your answer, go on to the next screen. The answer for part A is choice C, similar setup to the one that we did. And for part B, we're going to look at graphing it. So figuring out what the graph looks like for this problem. Pause the video when you have your answer, go on to the next screen. Alright, and our answer this time is choice D. That brings us to the end of Unit 2, Lesson 10 on graphing reciprocal functions.